Okay, in this video we're going to look at multiplying and dividing complex numbers when they're in polar form. So if we start with these complex numbers in rectangular form, this is what we've done before, where we multiply by expanding the brackets, which is all well and fine, and it works perfectly well so long as we've only got two brackets. If we've got three, then the expansion takes more than twice as long, and if we've got four, it takes longer still. The only difficulties here is remembering that your I squared equals -1, so you shouldn't have any I squared terms, and all simplify, and that's the answer to our two complex numbers z1 and z2 multiplied by each other. What I'll do now is I'll convert them into polar form. I have rounded to the nearest whole degree, so we've got z1 and now we've got z2 written in polar form. And we're going to look at how do we multiply these when they're in this form. Right, so we'll take a general approach first. So we'll say here's my first complex number in polar form. We'll call it modulus R1 and R2, and we've got cis of angles A and B. If we want to multiply, we'll just write them out in full first. Just a reminder what cis means. It means cos A plus I sine B. R1 and R2 are the two modulo, and A and B are the two angles or arguments. Right, if we multiply these two, you can see that we can multiply the two modulo, which is fine. And if I multiply the brackets, right, and we'll just have to do a normal expansion of brackets using the first term, just using FOIL, cos A times cos B plus I cos A times sine B plus, using the inside pair now, I sine A cos B, and the last or final pair, that would be I squared sine A sine B. Okay, now just get all the real parts and the imaginary parts separate. Remember, I squared equals -1. So here's the first term, and which is cos A and cos B, and we'll bring the final term using the I squared equals -1, so it's going to be a minus term just here. And we'll move the imaginary parts all in terms of I. So that'll be I, and this will be the imaginary part just here, sine A cos B plus cos A sine B. I just wrote these backwards because the formula sheet has them in this order, but it's the same thing. Right, so there's the formula sheet. If we look at the first one, there's the compound angle for cos A plus cos B equals this. Actually, sorry, that should be negative sine A sine B, not negative sine A cos B for the second term. Anyway, that's the expanded form of this compound angle, so we can use that backwards and say that's our cos A plus B. And the same thing here, this is the sine A plus B compound angle for sine. So if we can simplify it using those two rules, then we'll have R1, R2, and it'll be cos of A plus B plus I sine A plus B. And simplified still using cis, that's R1, R2, so we've multiplied the modulus 1 and modulus 2, and then we can add the two angles like that. So here we have a simplified version, and that makes it much easier to multiply in polar form. All we have to do is add the angles and multiply the modulus. Sorry, that should have been not 63, that should have been 67 degrees. So here we are using it for real to multiply the two numbers we started with in polar form. All we have to do is multiply 5 and 13, the two modulus, 13, cot cis, and we're going to add the two angles. So 5 times 13 is 65, cis, and these two numbers add to 120, and that's that. Easy as that. Much easier than even doing it in rectangular form. Just an extension of this. I won't prove it, but it can be proved very similarly, that it just means dividing the modulus and subtracting the angles for division of two complex numbers. Right, so I'll just plot these in Geogebra. There's the first one plotted, and Z2, as you can see, apart from rounding error, that's the two values there, because I rounded the angles. And if I take the first one, I'll take Z1, and I'll put it in brackets, and I'll multiply it. Then I'll paste Z2, multiply 2. We get this point all the way over here, and I'll just measure that line segment from there to the origin, and that distance is 65, which is what we got. 13 times 5 is 65, and I'll measure the angle. 53 plus 67 equals 120, so we get the angle right as well.